Okay, we're continuing to work with radical expressions, and what we want to do is figure out how we're going to add and subtract them. So real quickly here before we dive into this, the idea is the same as fractions that you've been doing your whole life. So suppose we wanted to add these two fractions, and somewhere in your past you saw the story that we need these to be sliced the same way. I've got half a pi and 1/3 of a pi, but I can't add these up because they're sliced differently. And so what you want to do is find what's the number that each of these denominators could turn into. So I could cut the slices the same way. Well, the number is 6, so if I do it to the bottom, I have to do it to the top. So I'm going to turn this into 6 by multiplying by 3. But if I do it to the bottom, I've got to do it to the top as well. Okay, well, we come over here, we want to make this 6. Well, let's multiply that by 2, but we've got to do it to the top. Well, that's the exact same thing that we're going to be doing. Our rational expressions are fractions. We can do the same exact thing. Now, we're eventually going to be doing that. We're going to make changes to the denominator that we've got to add to make the change to the top. But first, all we're going to do is try to find what is the number that it needs to become. Now, if you look what I've done over here, I turned both of these into 6. But what happened was this one had a factor of 2, and it needed the 3. So I gave it to it. Well, this one had the factor of 3 and needed the 2, so I gave that. So that these factorizations are the exact same thing. And that's what we're going to do here. So what we're going to do is we're going to use our factoring skills. So here's this first one factored, that's this side. And then, well, they've written this kind of in a weird way, but then we're going to factor this one. We get that here. So, okay, now we have them. So I'm going to do it. I want to show you like this. Okay, so we factored the one on the left, and we have factored the one on the right. All right, it's the same as above. One side had a 2, needed a 3. The other one had a 3, needed a 2. Well, let's look and see here what we've got. Well, they both already share the factor of x plus 1, so they don't need that. But this side is going to need an x plus 3, and this side is going to need an x minus 2. Now, once they have it, here is our least common denominator. And this is actually written incorrectly. It should be this. They actually made a mistake here. It should be x plus 1, x minus 2, and x plus 3. When these fractions have that as their denominator, we have a match. Now again, we're going to talk about if you make the change to the bottom, you got to make it to the top. But for now, we just want to start by seeing, can we find the least common denominator? Okay, so let's do it again here. So I'm going to factor these. Okay, so we need a match here. We need all the numbers to match. Well, the x minus 4 is matched, so I'm going to just bring that down here. That one's good. Now this side is missing the x plus 4, and this side is missing the x plus 3. But now that I've got them matching, that's our LCD. That's what they both need to become in order to have a match. Okay, let's keep going. As always, stop the video if you want to try that. Okay, so I'm just factoring. All right. Now, I'm doing it like this because I know where this is going to go, but you can just say, okay, what do they need to become? Well, what I'm going to need is they both have the x plus 3. So this side is going to need the x plus 5, and this side is going to need the x plus 6. Now, they match, so that's my LCD, x plus 6. Doesn't matter the order, they're all just being multiplied. Doesn't matter 2 times 3 or 3 times 2, it's the same thing. Okay. All right. I don't know what's different about this here. Oh yeah, okay, now we're addressing the change in the top. So let me just show you this. So now we're ready to already take the next step here. So let's factor the bottom. Okay, they both, that's supposed to be an x plus 1. That's hard to read. X plus 1. Okay, so they both have the x plus 1. So this side needs the x plus 3. Now let me pause here. I'm adding the x plus 3 to this side, but this is what we used to do with our old fractions. I can't just change the denominator. If I do that, I have to also do it to the top. And this side needed the x minus 3, so I can't just leave it there. I've got to do it to the bottom. I do it to the top as well. Now let me see if they're, yeah. So I'm trying to see, they're doing this in pieces, and I actually think just doing the real problems is maybe a little bit easier. But so we added it to the denominator, we're going to add it to the numerator. So here's our LCD, and we've adjusted the numerators, the tops, so that they had what they needed. So we added x plus 3, so we matched it, x minus 3. Okay, so we're going to adjust these. They're telling us already what the LCD is, so we're just going to okay, so I've factored those. So they already told us, but as you can see here, what we're missing on this side is an x plus 4. So if we need it down there, we got to add it to the top. And over here, we were missing the x minus, or the x plus 3. So if we give it to the bottom, we've got to give that to the top. Try another. Again, they're telling us the LCD, but we can find it for ourselves if we wanted. Okay, here's our LCD, but we could find it. This side needs an x plus 5. So if we give it to the bottom, we've got to give it to the top. This side needed an x plus 6. If we give it to the bottom, we got to give it to the top. Okay, we're going to do this with different denominators. Now we're just adding them. So this is exactly like we've always done. Yeah, I don't like, let me show you. So just in case you're rusty with this, so I'm going to show you doing it the same approach that we're doing now. Now you could go, okay, what do we turn both 12 and 18 into? And that may not be that easy to see. But if you break it down into its prime factorization, it becomes much easier. They've already both got this 3, and they both share a 2. So what are they missing? Well, this side needs another 3, but if I give it to the bottom, I got to give it to the top. This side needs another 2. If I give it to the bottom, I give it to the top. So now I've got 21. And then if we're going to crunch these numbers out, what do I have here? 4, what do I got? 9, 18, 36. Okay, now they're cut the same way, and we can do it. So you did this game before, and probably just looked for the numbers in your head. But this is how you can really do it, is you're breaking it down into the prime factors. You're adding the factors on each side that are necessary to get the match. And that makes 31/36. Okay, try it on your own if you'd like. I'm going to work it. Now I'm going to break it into the pieces. Okay, this is a match. This is a match, so I don't need those. But this side needs another 2. Give it to the bottom, you got to give it to the top. This side needs a 5. Give it to the bottom. You got to give it to the top. So here I've got 22 now over, let's see, 15, 30, 60. They're now sliced the same. We can put them together. Right, let's do another one of these, and then we'll get back to rational expressions. Okay, we've got matches on some 2's. This side is missing the 5, however, so we're going to give it to the top and the bottom. This side is missing the 2. Give that to the top and the bottom. I've got 15 over 10, 20, 40. There we go. All right, now let's do one. Let me see if they've done it away. Yeah, well, I don't like the one. Let's do it ourselves. So we're going to break this down, and I'm, excuse me here. I'm going to show you all the numbers broken all the way down. So just in case, again, if you see how to do this without this being necessary, that is totally fine. It is not required to do this, but I'm just showing you this is what it's all about. So let's circle some matches here. Okay, now that's what matches. Now this side on the left is missing the 7 and the y. So I'm going to multiply this side by 7y on the top and the bottom. Now this side is missing 4x. So I'm going to multiply 4x on the top and the bottom. Now I've got 35y on the top. What's our common denominator? I've got, it's got to be a big number. So it's 21 times 4, 20, 42, 84, I believe. And we've got 2 x's down there and 2 y's. Now 4 times the 4x gets me 16x. Okay, now we did this so that our fractions are now cut the same way. The pi is now cut the same way. Even though this is weird, it's all one number. We add this up. Now be careful here. Notice that this top, there's really nothing you can do with that. That's the best you can do to combine it. And there we go. Okay, pause it if you want to try it on your own. I'm going to break it down. Okay, let's do our matches here. We've got A's match, got a B that matches, got a 3 that matches. So this side on the left needs another 2 and another B. So I'm going to multiply by 2B on the top and the bottom. It's got to be balanced. What do we get here? 15, 30. We have a couple A's and a couple B's. Okay, over here we've got, we needed, let's see, we needed the 5 and the A. So I've got to multiply 5A, top and the bottom. Okay, now the slices of pi are the same, so I can add them up. And there we go. Oh boy, more of these. I keep doing the same. I don't know. Hold on. The book is very good, but they're doing like 3 of everything. Well, we'll keep going. I'll do one more. What the heck? Okay, I've got them in their prime factorizations. Now let's mark the matches. Okay, this side is missing a couple of D's. I'm going to write it as D squared on the bottom. Got to give it to the top. Now this side was missing just the 2. Give it to the bottom, got to give it to the top. All right, now our pi is sliced the same way, and so we get 5d to the second plus 6 over 16cd squared. Now, we're moving towards something that's going to require our factoring skills a little better here. Look how this works now. Yeah, down here, follow me here. I know there's a lot on the screen, but I'm going to save myself some writing and jump to this. So if we start with this problem here, this side is missing the x minus 2. So we're going to give it to it. But if we give it to the bottom, we give it to the top. Now here we need the x minus 3. If we give it to the bottom, we give it to the top, which is what I have in this lower box. Now, what we're going to do now is we're going to tidy things up. Now, leave the bottom factored, but this top I just distributed through 3x minus 6, 2x minus 6. Now, we're going to combine. Just let's add this up. These terms combine, so I get the 5x minus 12. And where we're going with this is sometimes we're going to get a numerator here that could be factored again, and maybe it'll cancel with something on the bottom. But for now, this doesn't cancel. I can't factor that any better, and that would be my final answer. Okay, so this side needs an x minus 2. I give it to the bottom, I've got to give it to the top. This side needs an x plus 3. Give it to the bottom, I got to give it to the top. Now factor that out. I've got 2x, or multiply it I should say. Now I'm multiplying this one through. Now remember, these are written the other reverse order. With multiplication, it doesn't matter. So these are sliced the same. This is really the same thing. So now, if the bottoms are the same, if you've got 1/4 plus 2/4, that's 3/4. We can just add the top and leave the bottom the same. So I'm going to add this top. I've got 2x's plus 5 more. I've got 7x. I've got 6, and then minus 10. And there we go. Now we will get to the point where we're going to need to see if we can factor this and see if anything cancels, but so far it does not. Okay, I'm going to save myself some space by this side needs an m plus 3, and this side needs an m plus 4. But if I give it to the bottom, I give it to the top. Now I'm going to FOIL this out or distribute it. I've got 3m plus 9. Now I know I wrote this the other way around, but you can still distribute this. It doesn't matter which side. I'm getting 4m plus 16. Okay, the bottoms now match, so we can do the tops. Got 7 m's on the top plus 25. Okay, do we have, yeah, we're getting a little more complicated here. Let's see if I can take theirs. So they have factored both of these sides. Yeah, I don't think that's legible enough to be that helpful. Let's do it ourselves. On this side I can pull out a b, so I'm left with 2a plus b. Over on this side we're factoring this down and we're getting 2a minus b, 2a plus b. Now if you weren't sure on that one, I've got a square root on the front and the back, and the square root of the front is 2a. Okay, let's go through it now. Now this side is missing a 2a minus b. Give it to the bottom, I'm going to give it to the top. This side is missing a b. Give it to the bottom, you got to give it to the top. Now I'm going to distribute this with 2a minus b up here, so I'm going to get 4a squared minus 2ab. I'm going to write this denominator just so that it looks the same as the other one, but it, oops, sorry, that should be a minus b. They look the same, but the order doesn't matter, remember. Okay, so they're sliced the same way. Even though these are crazy looking numbers, they're just numbers. So let's start putting it together. I have, do you remember, it may have been a while, ABs are the same word. So minus 2AB and 3AB, they go together. Now there's nothing to join with the 4A squareds. But I can put them together to make 1AB. Okay, hold on, I think here, did they do anything? Yeah, they put them together and then factored out an A. So this is what I got on the last screen. They then checked to see if anything could factor out of there and cancel. So they pulled out an A, but nothing cancels. So I'd be okay with either of those answers. Okay, let's do it again. Pull out Y out of there. Now this is a binomial that perfect square binomial. You can factor this. Square roots on the front and the back. Okay, now this side is missing a Y. Now I've done this in a weird order because I was trying to match this side, but so I need a Y on the bottom, I'm going to put a Y on the top. This one needs an X plus Y, so I'm going to give that also to the top. Now on the top here we've got to distribute this. We get 5x squared plus 5xy. Over here we've got 2xy. Okay, now xy's are the same word, so they can go together. I'm going to write up here and go 5x squared plus 7xy all over. This must be an x. Okay, now there's a GCF here of an x, which I could pull out, but it's not going to cancel with anything on the bottom, so I would just go ahead and leave that. Okay, let me check where we are in the big picture here, see if there's anything else in this section. Yeah, we've got one more idea here. So, I don't know if you need this many examples, but I'm doing it, so let's just keep right on rolling. Okay, so I've factored. Now if you look, we're trying to make our least common denominator. This side needs a 2. So if I'm adding a 2 to the bottom, I got to add it to the top by multiplication. This side needs the m plus 1, top and bottom. Okay, let's FOIL this out. Which should just say multiply it. It's not really foiling. Okay, over here I've got 8. All right, now our slices of pi are the same, so let's add up the numerators. We've got 7m plus 15. All right, nothing pulls out of the top there, so I'm done. Okay, now what I'm imagining is going to happen is that when we do the same process we've been doing, we're going to get something on the top we can factor down. So I'm going to jump ahead and see what they've done. They factored everything. We needed an x plus 3 over here, and over here we needed an x minus 3. Okay, well they've done all that, multiplied all through on the tops, just like we've been doing, and then they combine their like terms. And so now, well they've done this in several steps, they're just adding it all up on the top. That's the slice of pi on the bottom with the LCD. Yeah, it's not right. Okay, so if we're putting this together right here, we'd get 3x squared plus 17x plus 24. Okay, now 17 is prime. So this cannot go any farther. This isn't going to work. Well, am I right about that? Well, perhaps the AC method, it tells us it's prime here. So this is prime. We could have searched for a while. Where the next section is going to go is this numerator is going to break down and we'll be able to slash it, but that's the entire next video. So we're just going to assume here that this can't go any farther on these last two examples. So 2 more here and then we'll be done with this. You can always skip ahead if you don't need it. Okay, so this side needs an m plus 2, so we'll give it to the top. This side needs an m minus 2, so we'll give that to the top. Alright, now we multiply. Now 1 times m plus 2 is just m plus 2. I'm not going to write that whole bottom out here. I'm just going to do this. So we've got 5m squared minus 10m. Alright, it's all over that LCD, but I'm going to save myself some heartache here. Now, let's add up 5m squared minus 9m plus 2. Alright, now I'm assuming this is prime, just because they're in that section. And if it is not, we'll see in the next one that we'll be able to break that down. Is that prime? Yeah, that is prime. Okay, so if you want to see it, I'll do this one last one. Same thing though. And we'll deal with numerators that can be refactored in our next video. No, that's not right. N plus 3, n plus 2. Okay, they share the n plus 2, but this side needs the n minus 5. Give it to the bottom, I got to give it to the top. This side has the n minus 5, it needs the n plus 3. Give it to the bottom, I give it to the top. Alright, let's multiply this out. I get 2n squared plus 6n. And again, I'm going to save myself writing that LCD. This is going to give me 6n minus 30. Now we combine our like terms, we get 2n squared plus 12n minus 30. And now I'll write that LCD. Remember, the order that you write this doesn't matter as long as all the terms are there. It's the same thing. And there we go. Okay, so that is the beginning of adding these rational expressions. We're going to subtract them. We're going to have some that we can reduce further, but that's all for now.